In this video, we'll take a look at notes for section 9.4, hypothesis test about two dependent samples, and these would be matched pairs. So our example comes from the textbook. It's problem number 13 in the exercise. It says, speaking couples listed below are the numbers of words spoken in a day by each member of 6 different couples. The data are randomly selected from the first 2 columns in dataset 17 from Appendix B. Use a 0.05 significance level to test the claim that among couples, males speak more words in a day than females. So we've got two sets. We have male and female data, but notice the matched pairs, they're from couples. So what we do is, first of all, let's check the requirements. Requirement number 1 is the sample data are dependent. They're matched pairs in some way. Since these come from male and female couples, that satisfies the first requirement. 2, the samples are simple random sample. These two were chosen at random from the data set in the back of the book, and the data set was also a random sample, so we satisfy requirement 2. And then number 3, either or both of the conditions is satisfied. Either the number of pairs of sample data is large, and in our case it is not, or the pairs of values have differences that are from a population having a distribution that's approximately normal. And then these methods are robust against departures for normality. So for small samples, the normality requirement is loose in the sense that the procedures perform well as long as there are no outliers and departures from normality are not too extreme. So when we take a look at our requirement 3, the test that we're actually going to run with the male and female data is we're not going to run male independently from female. We're actually going to subtract the 2 values and then run a test on a single set of data, and that single set of data is going to be the difference between the 2. Okay, so the first thing we want to do is find those differences, and if we want to test if males speak more words in a day than females, then if this is true, then the difference of male minus female would be greater than 0. So what we want to do is use the calculator to actually do that. There are only 6 items, so you could subtract these by hand and it wouldn't take very long at all. But I'll show you how to use the calculator to type each of these in a list and then use list operations to do the subtraction all at once. So on our calculator, let's go ahead and go to the edit and type in male in list 1. 5638. This is what takes the longest time. Let's see, 17, 572, 26, 429, 46, 978, and 25, 835. All right, I just want to double check that I put those in correctly. I think I'm okay. Then in list 2, we type in the matched pair. So this male, we have 5198 for female. Type in our second value. Third value. $13,397. 31,553. And 18,667. All right, now that we have our first list male words, second list female words, we want to use list 3 to take list 1 minus list 2. And the way you can do operations with the lists is you use your arrow key to get you up here in list 3. And then down below here, this shows up, we're going to type a formula. We're going to take list 1 minus list 2. And the lists are in yellow right above the number 1 key. That's an L1. So we're taking second, the number 1, minus second, the number 2. L2 is written above. And what that does is it will take every value in list 1 and subtract every value in list 2. And that's what our list 3 is. So this means that males, in this couple, the male spoke 440 more words. In this couple, 9,658. This is less, more, more, and more. So you can find the differences really quickly by using your calculator. All right, then, to check for normality, We use a normal quantile plot like we did in Chapter 6. So let's go ahead and do a stat plot. Let's see, that would be second y equals. Stat plot's on. And the normal quantile plot was the last one. There we go. Our data list this time is in list 3. So we have to tell it that our data is in the number 3, which is list 3. Go ahead and click enter. Oops, and graph. Oops, sorry about that. Let's go back to that stat plot. It's not graph that we want, it's zoom and then 9. And that automatically sets our window so we can see our points. So our 6 points line up in a pretty straight line. So actually it looks like they are pretty normal. These 6 differences, so we're okay. We've got the requirement satisfied with our normal quantile plot. All right, so next we want to state the null and alternative hypotheses. So just a reminder, we're not comparing two means, we're not comparing males and females. We're doing one test on the differences. So the notation, the D, those are the individual differences between the two values in a single matched pair. The mean subscript D, mu D, is the mean value of the differences for the population of all matched pairs. D with the little bar across the top is mean value of the differences D for the paired sample. So that's our, instead of an X bar, we have a D bar. S sub D, standard deviation of the differences in our paired sample data, and N is the number of pairs. So we only have 6 pairs. So our null hypothesis is that the differences between male and female words equal to 0. So there's no change. That means that the number of words males and females speak, no difference. The alternative hypothesis is what was the claim, is that we think that the differences are greater than 0. Since we took male minus female, that means the word count would be greater for males. All right, so when we perform the hypothesis test, it's a single set of data, so we use the same test that we did back when we were doing t-tests. So on our stat, go over to tests. This is just a t-test. We're putting data in this time because it's actually in our list. What we're testing against is 0. Remember that that's 0. Our list is not in list 1. Our actual data is in list 3. That's where our differences are. And then our test is a one-tailed test of greater than. And we'll go ahead and calculate. So here are our results. Our test statistic is 2.578. And that shows how many standard deviations we are from 0, how unusual it is for, if your mean is 0, how many standard deviations the number of male words is, or the differences between. Our p-value is 0.0247. It gives us our mean difference, which is 7278.5, and the standard deviation of our set. So here's the interpretation of our findings. The reasoning, the p-value 0.0247 is less than the 0.05 significance level given. That means we'll reject the null hypothesis and evidence supports the alternative. So that's our reasoning, our actual conclusion in the context of the problem. There is sufficient evidence to support the claim that among couples, males speak more words in a day than females. And there's our p-value. Okay, we'll also run a confidence interval. And what a confidence interval does is based on your sample, it gives you an interval that we think the population might be in. So our confidence interval is a t-interval. So we go to stat, over to tests, down to a t-interval. And when you do this right after your hypothesis test, all of your data is saved. So let's input data again. It's in list 3. And then our confidence interval, remember that we had a one-tailed 0.05 significance level. So a confidence interval, remember, is the middle percentage. We have 0.05 on one side, so we have to allocate 0.05 on the other side. So our confidence level is 90%. When we calculate, we end up with an interval of 1591.4 to 12,966. So this actually has the difference in the number of words. So here's our interpretation. We're 90% confident that among couples, males speak on average between 1591.4 and 12,966 more words per day than females. So also notice that 0 is not in our interval, our confidence interval. So that supports our findings in the hypothesis test. 0 is not in there, and these are all positive values. All right, so there's matched pairs. It's really just a one sample t-test of the differences between the two sets.